Okay, reading from the top, this is about what happens when exponential growth is not a good model. So a very big scientific principle is the idea of modeling. And I'm going to pause for just a second because Kaylee probably doesn't want to hear this, and say that these other growth models are what happens when the problem tells you how to set up the growth model. We're going to start with number one. The rate at which a population increases, stop. Just stop right there. We want to translate these words into symbols directly. The rate at which a population increases is this little differential right there, dy over dt. We're going to translate the word is into the symbol that means is. We're going to translate directly proportional to into k times something. That's what directly proportional means. It's a constant times something. And then what's it directly proportional to? The square root of y. Not just y, but the square root of y. So given all of that, if it's directly proportional to the square root of y, we have a differential equation. Do you see how this is very similar to what we just did right here? Instead of being k root y, it was ky. This is just a different growth model. So now it says solve the differential equation subject to these two initial conditions. There are two initial conditions because you have two unknowns. You have the unknown of what is k, and you also have the unknown of what is the constant of integration, the big C value. So we're going to solve for both of those. To start, we're going to first try to separate this. It's a separable differential equation. Tomorrow and the next day, or the next day, we deal with the ones that you can't separate. But this is separable, meaning I can divide both sides by root y, and I can multiply both sides by dt to get k dt, and we integrate both the left side and the right side. So integrating the left side means this is really y to the negative 1/2 dy integral, and the integral of k dt. So when I integrate y to the negative 1/2, I'm adding 1 and then dividing by that same thing. This is 2 root y equals kt plus a constant. Okay. We now can start to try to solve some of these things. We're not going to be able to do everything, but I'm going to start to maneuver this to try to solve for some of the variables. Starting with this one, y of 0 is equal to 25. Plug 25 into root y. 2 times that is 10. We get k times 0 plus c, which means that c is equal to 10. So I at least know that. I know that c is 10, which means if I kind of rewrite what I have here, I now have 2 root y is equal to kt plus 10. I could plug in, and I could divide by 2, whenever I want, but let's plug in the second order pair and see how close if we can get k now. So I'm going to plug this in, and I get 2 times 10 is equal to 5k plus 10. That would be 10 is equal to 5k, or k is equal to 2. Putting that back in, we get 2 root y is equal to 2t plus 10, or root y is equal to t plus 5. And now let's get the y by itself. Y is equal to t plus 5 squared. And that's your other growth model solved with those two initial conditions. You can usually tell that it's decent because it looks clean. It's a nice one to work with. Let's check the units. It says t is measured in weeks. way up here, and the reason I'm checking the units is because the next question says, what is the size of the population after 15 weeks? That's an easy question once you have your differential or your equation, your solved equation. We know that y is equal to, technically this is y of t is equal to t plus 5 squared. So a way to show that without showing too much is to say y of 15 is equal to what? 400. And let's check the units of that. The rate, y is the population, so we don't know what it is. We can just say 400 whatevers. And then it says, when will the population reach 1,000? This is 1,000 is equal to t plus 5 squared. Does 1,000 have a perfect square root? No, its square root is 10 root 10. So 10 root 10 is equal to t plus 5, or t is equal to 10 root 10 minus 5. And you can approximate that. I want to remind you guys, without wasting the time of opening it up today, that you can go to your graphing calculator. You can plot y equals x plus 5 squared, and you can plot y equals 1,000, and you can see where they cross and get an approximation that way as well. Whichever way is faster. If this is a calculator problem, it might benefit you to graph it, may not. Just depends on how fast you are with your graphing calculator. Yes, Kendall?
Is that supposed to be 10 root 10?
It is supposed to be 10 root 10. Thank you. Okay, aside from the lacking period in this next sentence, there should be a period there at the end of constant. Newton's law of cooling says that the rate at which the temperature of an object decreases is proportional to the difference between the temperature of the object T and the temperature of the environment, which is a constant. Okay, we want to translate this into a differential equation, again, based on what it says. So the rate at which the temperature of an object decreases. What can I classify that if the temperature itself is big T? Yeah, we'll do big T, d little t. Is proportional, which means equals k times the difference between the temperature of the object and the temperature of the environment. Now, here's the issue. I don't know what the temperature in the environment is unless I start reading the question, which says a cup of coffee with an initial temperature of 95 degrees Celsius is placed in a room that's 21 degrees Celsius. So I can just say that this is T minus 21 because that's my constant environmental temperature. Okay, next. Solve the differential equation given the temperature of the coffee is 85 degrees Celsius after 1 minute. Well, let's back up a second. Did we truly write a differential equation up here? It says an initial temperature of 95 degrees. We have a differential equation here, but I don't know what K is. But I might be able to figure out what K is if I actually truly solve the differential equation. So the differential equation is 85 degrees after 1 minute. This actually means we have two ordered pairs. I have the ordered pair 0, 95, and then 1, 85. Does that make sense? The problem in part B specified the second order pair, but the original problem specified the first. And much like before, we are not only trying to find K, we're also trying to find C. Those are the two variables we're going to try to find when solving this. It is a separable differential equation, which means I can divide both sides by t minus 21 and multiply both sides by dt, d little t, and we integrate. When I say separable, I mean that you get all the variables of the same kind on the same side. And that little k is not a variable, that's a constant of integration, or not constant, that's a proportionality constant that we need to solve for. What's the integral of the left side? What's the integral of t minus 1? Natural log t minus 21 equals kt plus a constant. It's your call about when you actually try to solve for k's and c's. You can plug things in now, or you can plug them in a little bit. I'm going to choose to go a little bit here because I'm going to try to get rid of the ln. This means exponentiate both sides with a base e. And since these are notes, I'm going to show this out in painstaking detail. E to the natural log of t minus 21 equals e to the kt plus c. And if we simplify, the left side becomes t minus 21. And for reasons that we have been working with for a while, especially because this is the same as e to the kt, e to the c. Remember, e to the c is just another constant. C, e to the kt. And I'm going to now go back and rewrite history and put a little 1 on all these, because this is now a different constant. Still want to solve for that constant. But I now have t is equal to c e to the kt plus 21. So now it's going to be a little bit easier of a task to figure out what k and c are, given that I have two ordered pairs. The first ordered pair knocks out one of the two variables. If I plug in 0.95 into this, I get 95 is equal to c plus 21, which means that c is equal to 74. So I'm going to put a little save break here and write t is equal to 74 e to the kt plus 21. And now we're going to plug in 185. So I've got 85 equals 74 e to the k plus 21. Subtract and divide, and you get 64 74ths equals e to the k. This means that if I take the natural log of both sides, I get the natural log of, this would be 32 37ths equals k. Now I'm going to do something you can't, which is to take all of this and slide it to the left so I can give myself more space. If you're already in the habit of starting as far left as possible, you're better than me. But I'll plug that k back in, and I get t is equal to 74 times e to the natural log of 32 37ths to the t plus 21. And I wrote it that way because what's e to the ln of 32 37ths? 32 37ths. So this is my full simplified equation. 74 times 32 to 37ths to the t plus 21. How many minutes will it take for the coffee to cool down to 51 degrees Celsius? That's a question of two ways. One is the graphing way, but let's be fun and not do the non-graphing way for a second. This is good practice in solving exponentials. So we're going to subtract 21 and divide both sides by 74. That gives me 30 74ths, or 15 37ths. The best way to deal with this now is to take a natural log of both sides. I'm going to pause for just a second. Natural logs and kind of working with that. Because I'm going to take the natural log of the left side, 15 37ths, the natural log of the right side. You remember what that exponents can do, right? It can come out as a coefficient. So I would get t is equal to, well, I should write it with the coefficient in front first. This is t times the natural log of 32 37ths. So you get t is equal to the natural log of 15 37ths over the natural log of 32 37ths. There really isn't a great way to simplify that, and I wouldn't ask you to. Remember, this is calculator ready. and any scientific calculator you use could calculate that. If you wanted to make it a little bit cutesier, you could do things like break it up into the ln of 15 minus the ln of 37 over the ln of 32 minus the ln of 37. But it's not like you can cancel out those ln of 37s. You could even get even crazier and say that this is the ln of 3 plus the ln of 5, and this is 5 times the natural log of 2. But all that is just kind of reducing out the same thing. This would be more than fine because any problem on this would ask you to have a calculator. Furthermore, remember you could take this and graph it. Graph the right side, graph y equals 51 as the left side, see where they cross, and get an approximation that way. So I'll let the reader, viewer get the approximation, and we'll move on to the next one. At time t, the volume is increasing at a rate proportional to the reciprocal of its radius. Just slow down. If it looks like all those words are kind of a common, just slow down, take it in steps. The volume of the sphere is increasing at a rate. Let's start with that. dv dt. And that is equals proportional, means k, to the reciprocal of the radius. Okay, we've got a slight issue here. I have dv dt on the left, and I have 1 over r on the right. I don't quite have the same little things happening. I need basically a relation between what's happening between volume and what's happening with radius. What is the volume of the sphere, by the way? What's the formula for the volume of the sphere? 4/3 pi r cubed. Volume's a cubic thing, so you need to have a cubic factor in it. We can do that. I can say that means that in this moment, we could solve for r, and that would give me a little bit of what's going on here.
Do you also take the derivative of both sides?
Let's try that. If I do derivative dv dt equals 4 pi r squared dr dt, then we have r dt, and we can plug that in, and everything will be in terms of r. So that's a better approach to kind of take this, plug it in, and I would get 4 pi r squared dr dt equals k over r. You've got to be thinking we want to get the r's on the left side and the t's on the right side. Oh, so that should be k over r, my bad. That's better, right? Okay, now, like I said, r's on the left side, so if I divide both, or multiply both sides by an r, I'm going to get 4 pi r cubed dr, and if I multiply both sides by dt, I get k dt. Now we integrate. This is going to be pi r to the 4th equals kt plus c. Then it says at time equals 0, the radius is 1. This means I have an ordered pair of 0, 1. So if I plug 0 in for t and 1 in for r, I get pi is equal to c. So let's do a little break, and kind of pi r to the 4th is equal to kt plus pi. And now my second ordered pair is that at time equals 15, the radius is 2. Yep. So this is 16 pi is equal to 15k plus pi. Look at how that works out. K is 1. And now I can plug in that and get pi r to the 4th Oh, it would be pi. Pi to the fourth is equal to pi t plus pi. That's nice. Which would be r to the fourth is equal to t plus 1. And if I want to get the r by itself, t plus 1 to the 1/4, or the 4th root of t plus 1. Yes?
How do you know which value to plug in to reach like the radius? So like 0, like how do you know to plug that into t?
It says find the radius as a function of time. So when it says that, what I want to have is r of t written like this, where my equation is t comma r. So I'm trying to do everything like that. Additionally, it actually says up here at time equals 0, the radius is 1. So I'm specifying that t is time, and that's the first one, and radius is the second. I'm trying to be careful that I've created that ordered pair to be t and r that way. If you do it the other way, it's not the world's worst thing. It would still work. But at the end of the day, you still want to probably have it in terms of r and kind of read the directions to make sure you have the right independent-dependent variable. At what time will the volume of the sphere be 27 times its volume at t equals 0? There's a hard way and an easy way to do that. If the volume of the sphere is 27 times its volume at t equals 0, remember, at t equals 0, radius was 1. What do I want the radius to be if its volume is 27 times? What would the radius be? It would be 3. Sammy, why? You guys actually did this in geometry a little bit, where you learned that a linear quantity, if you look at the area, it increases it by a square factor, and a volume increases it by a cube factor. Since a sphere is a regular object, there's no variation, there's no undulation happening. When the sphere is 27 times its volume, its radius should be 3 times what it is. You could prove that and go a little bit of a long way and say that when radius is 1, then my volume, 4/3 pi r cubed, would just be 4/3 pi. And then 27 times that, if I multiply that by 27, that's going to be 36 pi. And then I would kind of work my way backwards to a radius of 3 for that. But I kind of like thinking that if it's 27 times its volume, its radius would have to be 3 times what it is. Okay, knowing that, isn't this just a matter of taking this and plugging it in and trying to solve for t? 3 equals t plus 1 to the 1/4 power, which means 3 to the 4th is equal to t plus 1. What would t be? 80. I think that's seconds. Nope, it doesn't have units. So t is 80. Okay, we'll start and see how far we get on this one. A new employee performs a job more efficiently each day. The rate at which an employee can make y widgets per day after t days on the job. That's a complicated way of defining your variables, but that would be dy dt. Guys, you're not going to have dt dy. That's another little clue for how this is going to work. dt's are always going to be your denominators. Is directly proportional, equals k times, to 80 minus the number of widgets produced. That would be 80 minus y. Solve the differential equation assuming 20 widgets on the first day, 0, 20, and 50 widgets after 10 days, 10, 50. Is this looking familiar to every other problem we've done now? Separate them. dy over 80 minus y equals k dt. Integrate. What's the integral of 80 minus y? Negative natural log of 80 minus y. Good. The negative will throw you because remember the derivative of 80 minus, you got that negative y in there. So if you did a u substitution of 80 minus y, your du would be negative dy. You have a negative by chain rule. Equals kt plus c. Now if I multiply both sides by negative 1, I'm going to get negative kt minus c. Well, I hate minus c. Let's make it plus c again, and I'm going to rewrite the previous c to be c1. Because a negative c is the same as a positive c, it's just a constant. Exponentiate both sides with the base of e to the negative kt plus c, which is the same as c e to the negative kt. It's a different c now, so guess what the previous two c's become? C2s. And finally, if I solve for y, I get y is equal to c e to the kt, negative kt, minus 80, or 80 minus that. Oh, sorry, it should be negative, right? That's better. Had my subtraction wrong. Let's plug in 0 for t and plug in that first order pair. We're going to plug this one in. I get 20 equals negative c plus 80, or c is 60. So y equals negative 60 e to the negative kt plus 80. Now let's plug in 1050. 50 is equal to negative 60 e to the negative 10k plus 80. Subtract 80 and divide by negative 60. I get 1/2 equals e to the negative 10k. Or natural log of 1/2 is equal to negative 10k. I've got a way to kill that negative right now. Isn't natural log of 1/2 negative ln of 2? So ln of 2 over 10. And now we get to plug that back in and try to do some fun little mathing. Y equals negative 60 e to the negative ln of 2 over 10
Devin Deary and Adam
t
Delumpa come to the D's office. Devin Deary and Adam Delumpa to the D's office.
plus 80. I'm going to try to make this a little bit clearer in a second with this. Let's make this e to the ln of 1/2 again and raise that to the t over 10. This is just some moving of numbers around because e to the ln of 1/2 is just 1/2. And that would be the simplified form. We'll stop there because that's the rest of the questions you can answer once you get that. One other little point. It's not a big deal if you keep it in this form. It's really, really, really not. You'd be using your calculator anyway, but I like moving it into the other form. Okay, I'm going to pause for finishing up this problem. The next question asks how many widgets is it producing after 30 days on the job. So let's do negative 60 times 1/2. T is 30, so 30 over 10 plus 80. This is the advantage of getting this equation into a form that has a base of 1/2. So I go negative 60. This is 1/2 to the third power, or 1/8, plus 80. Negative 60 times 1/8 is negative 60, 30, 15. This is negative 7.5, which I'm just going to write as a decimal, plus 80. Oops. Or 72.5 widgets produced after 30 days. Oh, hang on. This is my bad. This is not asking how many widgets they produced. I kind of messed that up, and I'm glad I did, because the question is widgets per day. This is a question about the differential equation. So we need to go to dy dt is equal to, we know that k was ln of 2 over 10 times 80 minus 30. Or this would be 80 minus 30 is 5. This is 5 ln of 2. And if I could pull my calculator out really quick and figure out what the ln of 5 times the ln of 2 is, which is the same as the natural log of 32. That is 3. So producing about 3.47 widgets per day. That was a question about rate. That wasn't a question about amount. The next question is an amount. After how many days will the employee be producing 70 widgets? So I need to go 70 is equal to negative 60 times 1/2 to the t over 10 plus 80. So if I subtract and divide, I get 1/6 is equal to 1/2 to the t over 10. Let's take the natural log of both sides. I get the ln of 1/6 is equal to t over 10 times the natural log of 1/2. Ln of 1/6 is negative ln of 6, and ln of 1/2 is negative ln of 2. So I can actually write this as ln of 6 equals t over 10 ln of 2. And then if I divide both sides by ln of 2 and multiply both sides by 10, I get t is equal to 10 natural log of 6 over natural log of 2. That's about as simplified as you can get for calculator ready modes. Because I'm out of class right now, I can go ahead and just calculate this. I'm typing this in my calculator, 10 ln of 6 over natural log of 2, and we get about 25.8 days. So you can say 25.85 days, or we can say 26 days if we want to round up. That's it. Your homework is both a worksheet and a book part. So at least in 2019, the book part was this, and the homework or the worksheet is this. And that worksheet should be a quick one to do. We're done.